A. Yeah, I see the stream is on its way. I should close to mute myself here. Okay, we wait till 7 p.m. So today I will run through 2 sample papers for both primary 5 and primary 6. So the first 1 hour, the 7 to 8 p.m. will be P5, and 8 to 9 p.m. will be P6. We maybe wait to 7:03. Yeah, we wait till 7:03 for parents to enter, for students to enter. Yeah, then we will start. So today is the run-through section for both TASMO P5 and P6 sample paper. So you can check the run-through and to find how well you can do and to decide whether you will enter the TASMO or not. So at the end, I will give you some point lines that maybe how many points you should get to win a gold medal and how many you should get to gain a silver medal. For platinum, right, so there is no limitation for platinum. So if students are clever enough, they learn good enough, so maybe there are 3 full marks in each grade, so the full mark can only get the platinum medal. Yeah. So just the gold and silver. Okay, we wait till 7:03 p.m. We'll open another channel, YouTube, and then mute myself. Okay. 1 minute left, and we'll start. As time is limited, so I will not run through all the questions. So for those which easy enough, right? So for those easy enough, I will just give you the answer, right? So just give you the answer. and to tell you what this is about. And I will mark those I think you should do it correctly. Yeah. So there are questions of an average level, so I think all the students who have learned this should have the ability to solve it. And for the questions with a little more difficulty, yeah, I will run through that questions and tell you. So this is a question. It's okay if you failed, but I think you should know how to do it after run through. Okay? Okay, now time's here, so maybe we just start. So the first 1 hour is about the P5. So we are talking about the TASMO sample paper in primary 5. So in both the primary 5 and primary 6, we have 22 questions. The first 10 questions, yeah, is MCQs and were 3 point each. And this is the easiest part. The first 10 questions is the easiest part. Also, it should be mentioned that if you choose a wrong choice, you will not get a minus score, just a 0 score. So you do not answer or answer it wrongly, it's always 0 score. And if you answer it right, you will get a full score. And each question should only have one answer. Okay, so the first 10 questions is MCQs. And the second section, yeah, is the short answers. You just need to write the answer down. That is okay. And here we will have 10 questions, each worth 4 points. And this part is more difficult than the first part. Section B is more difficult. Also the 10 question. And the section C is the open-ended question. There are only 2 questions, but worth 15 each. In these questions, you should write the necessary process, maybe the equation, or maybe the logic, maybe the words. So let me know, or let our teacher know, so how you solve this problem. And if you only have the answer, you may only get 3 or 5 points. You should put the necessary formula, necessary equations, necessary process down to win the extra point. Yeah, so there are 2 questions. And these 2 questions, yeah, I can tell you that one is easier and one is more difficult. So maybe you can choose to solve one question at the test. Okay, yeah, this is structure of our paper. And in P5 and P6, right? So P5 and P6 in the MO part, they are merely the same. P6 will include more knowledge, such as the Gaussian symbol, yeah, such as the circle and cylinders, yeah, something like that. Yeah, but merely they are the same, of the same level of difficulty. Okay, now let's start from the primary 5. The primary 5 question 1 is a very easy question, so I will mark it as, yeah, I will use the right mark to mark it. So this, when I mark, I mean this question is easy, so I think all of you should have the ability to solve it. So this is a very easy question of chain simplify. So you just make it into 5/3, 4/6, till 23/21, and 24/22. And then we will see that in each fraction, one's denominator is the numerator 2 behind it, the 2 in front of it, right? So 5 and a 5 here, 6 and 6 here, and 21 here, 22 and 22 here. So after simplifying, the only remaining thing will be just the first 3 and 4, and the last 23 and 24. And by then, we will see, now here, 3 and 4 and 24 can be simplified into 2. So the answer should be 46. Yeah, very easy to choose B. Okay? The second question is about the change in ratio, change in proportion. So the key point is to find the unchanged value. So in that case, so there are east and west, east running to west, west running to east. So what is unchanged? The sum is unchanged, right? We just mark the unchanged sum. And so firstly, east and west. So firstly, we do not know. And after 17 rounds from east to west, the ratio is 1 to 4. And then 28 from west to east. Make it into twice the number of the west. So 2/1, right? So now the key point is the total number of east and west remain unchanged. So here is 5 units, here is 3 units. We unified into a 15. And then we can solve the problem by find changing in the ratio. So the 28 was 7 units here, and we can get 1 unit, and we can find the answer, right? So here 1 unit equal to 4, and initially we have 329 in the east and 31 in the west, which means the difference is 2, and we should choose none of the above. Yeah. So I think this is an easy question as well. So just a simple change in the ratio, and also you can use the algebra to solve it, right? And question 3, we just skip it. So it's just about the A star 2A will just equal to 4A, and 4A, 3A will equal to 11A. So something like that. And you will calculate it step by step, and you will find the answer. So finally, we will get 57A equal to 570, this A into a 10, right? Yeah, this is an easy one. Also, now the fourth question. So it's about, it's a distance problem, but actually we can solve it in the efficiency problem way. So let's assume that, so there is an accelerator. So maybe we just assume the total distance of this hill to be 1. And here, Amy took 15 minutes to go from front to top. And in this process, the escalator is moving. So here we can see this 15 minutes took is both by Amy and escalator. So maybe we can see the speed of Amy plus the speed of the escalator equal to 1/15. And for Belinda, right? For Belinda, we have Belinda go upstairs with the escalator is 30 minutes, which means the speed of Belinda and the speed of escalator together is 1/30. And then we can see when the escalator stopped, Amy alone will take 20 minutes, which means the speed of Amy should just be equal to 1/20. Okay, now by the speed of Amy, we can solve the speed of escalator, which is 1/60. And then we can solve the speed of Belinda to be 1/60. Yeah. So again, we choose E. As the efficiency is 1/60, it will take Belinda 60 minutes, and there is no choice about it, so choose E. Okay? Now, this is the question you should get it correct. Okay, now we move to the question 5, right? So question 5 may be the only question that I think in the section A that you could fail, right? So now here, 1,000 fish. So there are 3 types of fishes. So the peacock fish, the clownfish, and the glowfish. So the peacock, glow first. Glow and peacock. So glow is 5U, peacock is 3U. We do not know the clownfish, and we just need to calculate. So what's the maximum value of the clownfish? So actually, the total number is determined as 1,000, right? At 1,000. So if we want the clownfish to be as large as possible, yeah, we should make the glow and the peacock, the G and P, right? So as low as possible. We should make this U as small as possible. So can this U be very, very small? No, because if U is too small, then the clownfish would be greater than the glowfish, but which is not correct. So here we can have, so the U must be small, but we should guarantee that clownfish is smaller than the glowfish, which means the clownfish is 1000 minus 8U, right? So this 1000 minus 8U must be smaller than the glowfish, the 5U. So this is the limitation of the value of U. So here we have 13U is greater than 1000, and which makes U as an integer should be no greater than 76. So 13 times 77 is 1001, right? So the smallest value of U, this smallest value of U is 76, which makes the maximum value of the clownfish is 1000 minus 8 unit of 76. So the answer here is 384. Yeah, so this question is a little bit difficult. So you may get a wrong answer, as you may miss that this clownfish should be smaller than the glowfish, which is the key point. We should use this inequality to solve the range of U and then find the maximum value. Okay, now this is the only question I think well-doing P5 student can make mistake. So the first 4 questions I think is the basic question, so all of you should get it correct. Okay, for question 6, so just about calculating, right? So it's about calculating the value remainder when divided by 45. So the point is, you do not just calculate the remainder by 45. It's too difficult. So instead, 45 equal to 5 times 9. So we should calculate the remainder of 5 and 9 separately, and then putting them together to determine the remainder divided by 45. Remainder by 9 is quite easy, as these are all multiple of 9. So maybe this value to be A. So A should just have remainder of 1 when divided by 9. It's obvious. And what about, right? So what about 5? So about 5 is quite big complex. So we should find the patterns here, right? So for 81, it's just equal to 1. The 14 power of 1 is just a 1. So yeah, maybe we'll just write step by step. So firstly, we just replace all numbers by the remainder by 5 here. And then we calculate each by exponent. So here, the 14 power of 1 has a remainder of 1. The 9 power of 2, the patern of 2 is by 2, actually, by 4. So patern of 2 divided by 5 is by 4. So it just equal to 2. And for 4, the pattern is by 2. So this is n4 and plus 1, which leads to a 1 more 5. So this number has a remainder of 1 divided by 9 and also remainder of 1 divided by 5, which means it has a remainder of 1 divided by 45. So we choose E. Yeah, so this question is just asked us not to calculate the remainder by 45 directly because it's too long, right? Separately, we calculate both 5 and 9, and then we put them together to get the answer. Yeah, this is a strategy. Okay, now this may be a little bit difficult. So this is a difficult question. And this is not a difficult question, but it's not a basic question, so just left a blank here, right? So for star mark, it's a difficult question. And for non-mark question, so it's just normal question. And for the right mark, it's an easy question, right? So 7 is an easy question again. So we just use all the angles to find. Maybe we can use the interior angle or the exterior angle, so both is correct. And I suggest you to just use the internal angle in this 5-sided polygon. Yeah, in this 5-sided, yeah, 5-sided polygon, right? So the 5-sided polygon has a sum of interior angle as 5 minus 2, right? And then the other several angles, so here is a 60 degree, here is a 90 degree, and only left for this angle, right? This angle is one circle divided by a right angle. So this is an 270 degree. So we minus the 60, 70, 90, and 2070 to get the answer. The answer is 50. End of story. So this is an easy question. Also, yeah, 8 is also an easy question. So we have BD equal to 18 and CE equal to 24, and they are perpendicular. So when we see two lines are perpendicular, so we just connect DE. So we know that for a quadrilateral whose two diagonals are perpendicular, so the area of this quadrilateral is just equal to BD times CE and times 1/2, which leads into 216. Okay, and then, what is, we want to find the area of ABC, right? So we get the BCDE. So what's the connection between BCDE and ABC? Actually, the connection is built on ADE and ABC. So we can see ADE and ABC, this is the common angle model, or aka bird head model, right? So we have the ADE over ABC should be AE over AB times AD over AC. So they're both a half, so it's 1/4 of it. Which makes, so now this is 1/4 of the total triangle, and down here should be 3/4, 3/4 of this triangle. So the area of ABC should just be 216 divided by 3/4, which leads into a 288. Should be easy question again. Okay, then we move to the question 9. The question 9 is a little bit long here, right? But it's just about the length. It's not about difficulty. Yeah. The difficulty, I think, is there's no more question. So here we can see the history of Nanyang consists of 100 episodes. So Xiaoming watched 47 consecutive. His father watched 65 consecutive. And his grandmother missed 18 episodes, and she never missed more than 3 consecutive episodes. So we should find the minimum number that they both watched, right? So now here, if we want the episode they both watched to be as few as possible, so firstly we should deal with the Xiaoming and his father, right? So Xiaoming watched 47 and his father watched 65, and they are all consecutive. So maybe we treat the 100 episode like this. So 1 to 100. And let's see, so the total length of 100 episodes, we want Xiaoming and his father watched the common episode they watched to be as few as possible. The key point is to make Xiaoming start from the beginning 47, and make his father start from the end, the last 65. And now we can see there should be some part that comes crossover, right? So the crossover length is, the shortest of cross length is 47 plus 65 and minus the 100 to make it into a 12. So even if we put Xiaoming and his father to be from beginning and the ending, there should always be 12 episodes they both watched, right? And then we just determine in this 12, so at most how many. So if you cannot see the screen clearly, you can turn your smartphone if you're watching a smartphone, right? So you make it into you turn your smartphone and you'll be okay. I tried. So you turn smartphone and it will be. So you may not see the question clearly, but the question is in your paper, right? So the question is already in the paper we give you. So you just, as long as you can see the solution clearly, it will be okay. The questions, we have already sent the questions to. And I think YouTube is much better. So if you cannot see it clearly on WeChat, you can see it on YouTube. Yeah, in YouTube, I see it on YouTube is much better. Okay, we continue. Yeah, so now there are list 12, which this is Xiaoming and father both watch, right? Okay, then, so in this 12, which focus on grandmother. So grandmother missed 18 episodes. So can grandmother miss all this 12? No, because grandmother never missed more than 3 consecutive episodes. So in this 12, so we have the grandmother may miss 2 and she must see 1. Also miss 2, see 1. So you can see in every 3 episodes, the grandmother must look at least 1 of it. So there are 12 of it. So divided by 3 is 4. So grandmother should watch at least 1 of the episodes. 1 of the 3, so at least 4 episodes in total. So there is no choice of 4, so we choose the E, none of the above. Okay. And the question 10, right? So the question 10 is about the Gaussian symbol. So this is about to solve the equation with a Gaussian symbol. So here we have 3x plus 5, the integer part of x, minus 49 equal to 0. So to solve this question, we just make x into the integer part plus the fraction part, or the decimal part. So then we make the original equation into 3 of the integer, 3 of the fraction, plus 5 of the integer equal to 49. And then we get 5, the integer part of x, equal to 49 minus 3 times the decimal part, the fraction part of x. Now as we can see, so the integer part of x should be an integer, right? So this is an integer. And here, this should be a multiple of 8. So it's smaller than 49, so what's the value of it? It should be 48, right? So this should be the 48. And then, which makes here to be 1, so this is the 1. So which makes the integer part of x is 6, the fraction part of x is 1 over 3. And then we want to find 3x plus 1, so it will equal to 20. So we choose 8. Okay, now this is the MCQ part. So this is the basic question. This is the basic question. So I think in this question, you should get 8 of it correct. You should get 8 of it correct. So if there are more parents complaining about the looking, so maybe I may try to make some adjustments. So we fit MCQ. So I think in the section A, in the MCQ of P5, you should at least complete, doing 8 questions correctly. Okay? Okay, I will try to make some adjustment when we enter the section 2. So let's see if it works. But I wonder. Let's see. Wait me for maybe a few minutes. I'll try to make the adjustment here. Can I make it A4 size? Yeah, I think so. So, yeah. Let me have a look. Did I send it here? Yes. So maybe. So will this be better? So will this be better in the WeChat stream? The parents in WeChat, should this be better? If so, just call 1. So can you see it more clearly here? Okay, let me just continue this way, right? Okay, now then we move to the section B, right? So move to section B. So in the section B, so the questions will be a little more difficult, but I will still mark the question. I will mark question which is beyond some students' ability, and the question I do not mark is just the normal question. So we have the easy question, normal question, and the difficult question, right? Okay, for question 11 is a normal question. So here we have the A, B, C. So A is the LCM of A, B, C. So which means A is both multiple of B and C. And B is the the greatest common divisor in single we call it highest common factor, right? So the highest common factor of A, B, and C. So which means B is the factor of both A and C. And A, B, C are all distinct. So the key point is C equal to the number of factor of A. So actually, we just remember that C is the factor of A. So the number of factor of A is its factor. So which means we can discuss from this A. A is largest. So if the value of A is a 9, then 9 would have 3 factors. It works, right? So 3 is the factor of 9. Then we can see B. B should be the common factor of 9 and 3, and B cannot be 3, so B can only be 1. The first one. Okay, the second one is about, if A is then 8, right? If A is an 8, then 8 would have 4 factors. And 4 is also a factor of 8, so it will work. And then for B here, so B should be the common factor of 8 and 4, and B cannot be 4. So B can only be 2 or 1. So we have the 3 number. Is there more? No, there's no more, because A equal to 7 to 1, so they all have no satisfaction of this answer. So actually, there are only 3 that are satisfied. So the answer is 3. This, I think, is an easy question. So as long as you can understand what the question is asking you, and you learn the basic number theory, you can solve it easily. Okay? For question 12, question 12 here is a proportion in journey problem, but which makes it a little bit complex. So here is A and B, they meet at C. So the first time X travel to C and Y travel to C, there's an encounter. And then the speed of Y remains unchanged, and the speed of X becomes half of its original speed. And then when X continue to B and come back to C, the second process is that now we have Y reach the A. Okay? So now we should find the distance between A, B, or just we can solve the BC as well. We can solve the BC as well. So here, maybe we just name the BC to be X meters. So how do we get the equation? So the equation comes from the proportion in their speed. So we know for the same time, the ratio of speed equal to the ratio of distance. So here, in the first process when they encounter, we have the speed of X, which is red, and Y, right? So the speed of X over speed over to Y in the first process is the distance of AC and BC, which is an X, right? It's the first process. What about in the second process? In the second process here, right? So X has traveled for 1X and 2X, and Y has traveled for 1,600. So you can see here, right? So the ratio of distance equal to the ratio of speed. And the ratio of speed is unchanged, so we can solve the question like this way. But the key point is, if you do it, you're getting a wrong answer, because here, we notice that in the process 2, the car X, right, so become half of its original speed, which means, so in the process 2, X traveled 2X at half of its speed. So my question is, if the speed remains unchanged, how far would X go? with half speed, he traveled 2x, and if the speed remain unchanged, which is 2 times of its actual speed, it would travel 2 times of 2x, right? So it should be 4x, which make here to be a 4x. So now this is, we suppose that this x traveled at the original speed. So then the speed is unchanged. The speed of ratio of speed remain unchanged. So these two are equal. Then we can solve it by crossing over. We have the 4 of the x squared equal to the square of 160, 1,600. And then we can see, so even if it looks like quadratic equation, but actually we can directly get the x squared, right? So the x squared equal to the square of 80, which makes x equal to 800. So then the total length of AB should be equal to 2,400. So now this is maybe the difficult question. Yeah, as we should use the ratio of speed, and we should calculate the change speed in the process. I think there is a similar question of it, which is more difficult. I see. It's question 15, right? So the 15 is the same type of question, and it's about climbing mountains. So A and B are climbing mountains, and when A reaches the top and get back to 150 meters, he meets B. But notice that one would have an faster speed when traveling down. So this is faster speed. Again, when this A, right? So come back to the bottom, we see the B adjust at half of the journey downhills. Also, we mark the faster part and slower part. So now here, this is also a question about speed changing. And when we see someone's speed change in the process, the key point is for us to make some changes on our own to make the question as if the speed is unchanged. Because if the speed changes, we cannot use the proportion, we cannot use many methods, right? So we want to make the question easier. The key point actually is to assume the speed remain unchanged. So how do we do this? We can just change the distance. For example, here, right? So we assume all A and B, their speed to be unchanged. And in the same time, we did not change the speed, we change the distance. We calculate the distance they can travel. So now here, for A, in this time, he traveled a total distance, which is then S, and a 115. But this 115 is traveled in his faster speed. It's 3 times than their ascending speed, right? So what if its speed remain unchanged? The speed is 1/3 of it, which makes, in the same time, the distance traveled would be also 1/3 of it. So it will make this A to traveled actually only S plus N 50, as if he kept the speed of the ascending speed, right? So the speed become 1/3, the distance traveled should be also at 1/3. And for B, there is no such a problem, as we can see, right? So for B here, as we can see, there is no such problem, as B haven't turned over. So B just traveled this S minus 150. So this is the process A, process 1. And in process 2 here, so A now here, he ascending for an X, descending for an X. So for the same reason, if A speed keeps unchanged and in the same time he descends, right? So he descending the mountain for an S. So if his speed becomes 1/3 of his speed, so the distance traveled would be 1/3 as well. So then A should travel the first S at the normal speed and 1/3 of X at the time when he descending the mountain, right? So now actually, if A's speed remain unchanged, it will travel only 4/3S. And for B here, So B traveled 1s ascending, half an s descending. So for the same reason, we can see if B descending at ascending speed, so the distance traveled would be 1/3 of the actual distance. So it would be 1/3 of a half, which is 1/6. So that makes it to be 6/7s. Right. Okay, then now we make the A and B speed remains unchanged. Then the proportion in the speed would also remain unchanged. So we have the A over B speed. So in the first process, it's s plus 50 over s minus 150. In the second process, it's 4/3s over 7/6s. Okay, then, yeah, we can cancel the s here and get close over to have this one equal to this one. And then we can solve out the value of s, which is C, which is, I will find the answer here. Where do you put my answer? So I just close, sorry. I just close the answer I want to give you. So never mind, open it again. But I do not want to calculate it again. So it's too complex. This is about solution for 5. Yeah, sorry, I don't want to calculate it again. But the answer should be 1,550. Yeah. Okay, now this, right, also is a difficult question. Then we move back for the question 30 and question 14. Yeah, these two are all difficult questions. For question 13, so we should find 4 different prime numbers in ascending of order to form an arithmetic sequence, which is in the range of 60. So how to solve this? So the key point is, so there is P1, P2, P3, and P4. They have the same differences. So actually, the key point is to find the characteristic of the differences. So here, firstly, this difference must be an even number. Because if this is not an even number, so there should be 2 odd numbers and 2 even numbers in P1, P2, P3, and P4. But we all know that prime numbers are all except for 2 odd numbers. So if there are 2 even numbers, must be at least one that is not a prime number, right? So 2, D must be a multiple of 2. It's an odd number. It's an even number. And also, D should be a multiple of 3. So why is this? Because if D is not a multiple of 3, then we can see here, so P1, P2, P3, and P4. So as long if D, right? So if D has a remainder of 1 or remainder of 2 divided by 3, there should always be, we can see if D is not a multiple of 3, then there must be 2 among, there must be 1 multiple, not 2 multiple. It must be 1 multiple among it of 3. Because, right? So assume that D has a remainder of 1 when divided by 3, and P1 has a remainder of 1 divided by 3. So then plus 1 plus 1, so P3 would have a remainder of 3 when divided by 3, which is not possible. And if D, right? So if D has a divisor of 2, so 1 plus 2 equal to 0, so P2 is a multiple of 3. So which means, so the common difference here should be a multiple of 3 and a multiple of 2. So then we have, actually, the common difference should be a multiple of 6. Yeah, this is very important. So as long as we can define the common difference to list all the arithmetic sequence out, it will be easier, right? So the common difference could be 6, 12, or 18 shouldn't be larger, right? Shouldn't be larger. Yeah. So now here we check. So when difference is 6, it could be, there are 3 of them. And for 12, there are also 3 of them. So we just know, right? So as long as we know the common difference, we start from the smallest prime number 3, 5, 7, right? We can try, and it's easy to find all the sequences here. There is no skills in this part. It's just by listing. So totally 1, 2, 3, 4, 5, 7. Yeah, so totally 7. So this is a little bit difficult, and you should notice the characteristic in the difference. The difference should be an even number, which I think you can know, but it should also be a multiple of 3, because if not, there would always be one multiple of 3 among it, if depending on the remainder of D and P1. So no matter the case, there should always be nothing. Okay? Now this is the question 13. The question 14 is a word problem used the number theory analysis. So here are 3 men. So this Le, whose age can be A, his younger brother, whose name to be B, and his grandfather, whose age to be C. So now we have that. So this year, next year, and the year after next year. So Lolo's age is a multiple of his younger brother's age. So now if I write it, so is B is divisible by, A is divisible by B, A plus 1 is divisible by B plus 1, A plus 2 is divisible by B plus 2. If you look at this, you cannot solve this problem, because there are 3 different dividers and 3 different dividends. So how do we analyze? So can we make one of them be the same? Actually, we can, because we have this is an age problem. In an age problem, there is always one thing remains unchanged. That is the difference of age. Which means, right, if we find the difference of ages, now A is the multiple of B, then A minus B should also be a multiple of B, right? So B is divisible by A, then B should be divisible by A minus B, by the difference. So for the same reason, B plus 1 is also a factor of their difference, and so is B plus 2. And the difference is always A minus B, which makes B plus 1, and B plus 2. They are all factors of A minus B, right? So now here we can see, so A minus B must be the LCM of 3 consecutive numbers. So this is at least to be 1, 2, 3 equal to 6, which makes A should at least be 7. Maybe I just don't know to use the inequality. Yeah, they write it this way. Okay then, again for the same reason, look at A and C. So for the same reason, we have A plus 1, A plus 2 should be all the factors of C minus A, the difference of ages between Lele and his grandpa. Then we can see here, A is the smallest value of A is 7, so C minus A should be as small as 7, 8, and 9, which is 504. And you can see, so as C is smaller than 1000, so this is a limitation. So if B is larger, if B chooses a larger number, for example 2, then A should grow larger, which makes C grows larger, which will obviously beyond 1000. So this is the only solution. So the only solution for that is A equal to 1, sorry, B equal to 1, A equal to 7, and then C equal to 511. So this is about Lele's age, so this is 7. So this is a difficult question. So you should notice that the 3 consecutive years, the difference on age remain unchanged. So difference on age should be the multiple of the age of brother or age of mother. And then, so the difference of ages should be the common at least be the LCM of 3 consecutive numbers to get the range, and the only solution can get out. Okay, now, let's move on. For the question 16, right? So the question 16, I think is a normal question. So you can see here 6 teams participating in a tournament. So we can calculate, right? So this is about calculation in a small sport, right? So now we can see 6 teams. So each team will have 5 games to play, right? So each team will have 5 games to play. And so we can see the 1, 2, 3, 4, 5, 6. So now here we have difference of 4 here, difference of 4 here. And for the last one must have drawn 2 matches, which determines that the score of the 6th team can at least, right? So we calculate the minimum value of the score possible. So for the 6th team, he has drawn 4 matches. 1 draw equal to 1 point, so at least 2 points. And for the 5th, right? So it's greater than 6, so it adds 3. So at least 7 here, and then at least 8 here, at least 9 here, at least 13 here. So as we can see, so the minimum value of the first place score is 13 points. What's the maximum possible value of it? The maximum possible value is just 15, right? So he won all the matches, he would get 15, right? So the possible value for there should only be 3 different, so 16 or 14 or 15. Let's try about it. So firstly, so can it be 15? So if it equal to 15, to be the maximum, and then the Q should have the 11 score. The key point is, how do one get an 11 score in 5 matches? So in 5 matches to get 11 points, it can only be 3 wins and 2 draws, which means that the second team do not fail, right? Do not fail. And for the same reason, to get 15 score should win all the matches. So here is the controversy. So we can see the first team win all the matches, while the second team do not lose any matches. So this is the paradox, right? So this is not possible. So the first place cannot be 15. So can it be 14? Of course not, because at 14, if you play 5 matches, it's impossible to get a 14 score. So the minimum value is 13, and we cannot be 15 or 14. So the only correct value is 13. Then here, the minimum value is what we want. So the score for the third place is the 8. Right, it's the 8. Okay, then this is a normal question. And 17 is a difficult question. Yeah, I created this question in the 2022. So now here we have to use 1 to 9 each ones to form here, So the key point breakthrough point is about this 0.2, the decimal part. So how do we get the decimal part? It can only by this division here, right? So it comes from this division. So now here we can name E to be a 5, right? So E can only be a 5. So we determine the value of E. And then we can estimate the value. So this value is just, the largest of it is smaller than 100 divided by 20, right? So this is about smaller than 20 and greater than 2, maybe. Yeah, the range of this is around 2 to 20 of an 2-digit number divided by 5, right? And then we can determine the value of FGHI, the production of 4 distinct 1-digit numbers. So the production here should have the range of 182 to 200. So now the next part is to find numbers in this range that can be expressed as the production of two integers, one-digit integers. So actually, we can separate it into odd and even in two parts, because if the number is odd, then all the factors should be odd, so they can only be 1, 3, 7, 9. So this number is just 189, and which makes, right? So we come back, we have this minus c plus d to have its value to be 66. And we use up all the odd number, we try the even number. We use the even number 2, 6, 4, 8 to form 66. And it's quite easy. So as you can see, we can use the 68 minus 4 plus 2. Or you can use the 62 minus 4 plus 8. It's all correct, right? So B and D can exchange, right? B and D can exchange. But now here, A is 6 and 4, so it's 24. B times D is 16, so the answer is 40. So we start from the odd number, there's only one option, which is quite easy, right? For even number, it's more complex. We should analyze all the numbers between 182 and 200 to see if any number, we do the prime factorism to see whether one number can be the expression of the product of four distinct numbers. So there is only one number satisfied, which is 192, and it can be expressed in two ways actually. So it can either be written as, so I think there's this 1, 3, 4, 8, or be written as 1, 2, 6, 8. The two expression of it, but if this is a 192, we'll make this AB plus minus C plus D to be equal to 51. And if you try, you can see as 5 is used as E. So there is no possible value for this one. So actually, in odd, it's quite easy. So if you notice the odd, you can quickly get the answer. So if not, then we may have to try all these numbers. But I think it's also possible for you to get the answer, right? Yeah, so this is a 40. So this is 17. Question 18 is a basic question, right? This is a basic question, so even it's in here. So now this is about the swallowtail model, so or you can use the similar model, so as long as you like it. So this is 1 to 2 and 1 to 3, right? So we just connect AC to, if you want to use a swallowtail model, you divide it into this way. So now the area of this one, this is a U, this is a 3U, and because of the swallowtail model, so this is a 2U. And now this in total, this is 6U, and they separated it, so this is 2U and 4U. And then we can quickly get the answer, right? Okay, and then we can find the U, the value of U to be 5. And the total area of AEG and CEF is 5, 3U is 15. This is an easy question, so I skip this. So now, yeah. The 19 is a very difficult question, right? So this is a very difficult question. So you should notice that for question 19, 20, maybe 20, this 20 is easier. 19, 20, 21, 22, there will always lies 2 or 3 difficult questions. Yeah, actually 2 or 3 difficult questions. So you should be able to solve them. No. You may not be able to solve them, but that's okay. You can skip it. Yeah. You can skip them. So the difficult question always lies on this part. So this is a 2-star difficulty. Yeah, 2-star difficulty. Okay. So now we have the 3-digit numbers divided by the sum of digits, leaves the remainder of 1, which means we have A plus B plus C. So when divided by this number divided by A plus B plus C leaves a remainder of 1. And this number divided by the same sum of digits also leaves a remainder of 1. So here, the remainder is the same, which makes it to be a congruence problem, right? So two number shares a same remainder, the congruence problem, and then we can see the difference should be the multiple of the divisor, so which makes a plus b plus c should be divisible by this one, which is 99. Yeah, maybe step by step. So CBA ABC minus CBA, ABC is larger. So ABC minus CBA, which is 99A minus C. So A plus B plus C should be divisible by this. So it's the factor of 99 times A minus C. So obviously, right? Obviously, A minus C is smaller than A plus B plus C. So A plus B plus C should not be the factor of A minus C. It should be the factor of 99. So it can either have a factor of 9, or the factor of 11. And then let's see. So can it be, right? So then, can it be a multiple of 3? It's not, because if the sum of digit is a multiple of 3, then we can see 3 is, then ABC itself is a multiple of 3. But we know that ABC leaves a remainder by the sum of digits of 1. So which makes A plus B plus C is the factor of ABC minus 1. And we can see 3 is a factor of ABC, which makes, now here, this one is a multiple of 3. So 3 must be divisible, must be factor of ABC minus 1. But 3 cannot both be the factor of ABC and ABC minus 1. So this is not correct. So ABC is not a factor, not a multiple of 3. Then ABC must be a multiple of 11. Of course, it can be 22. Yeah, it can be 22. But 22 is easy to find, is impossible. So then we have A plus B plus C equal to 11. Okay, then we have the ABC here. So now we have the ABC here have a remainder of 1 when divided by 11. And the one number's remainder divided by 11 is determined by A plus C minus B. So then we have A plus C minus B have a remainder of 1 when divided by 11, which makes A plus C will just equal to B plus 1. And also we can see A plus B plus C equal to what? Equal to 11. And then we can get the value of A and B. A plus C, right? So we cannot get A, but A plus C is a 6, and B equal to 5. So as you can see, AC is distinct, and they cannot be 5. So the only way is to be 4 plus 2. So the answer is A equal to 4, B equal to 5, C equal to 2. So it's 452. This is quite a difficult question, I have to say. Yeah, so this is question 19. Question 20, I think is easy. So it's about to flip a number into another. So how many numbers can be flipped? Or how many digits can be flipped? So there are 0, 1, 2, 5, 6, 8, 9, right? So 6 digits can be flipped. So as long as we use the 2 numbers that can be flipped to form a 2-digit number, the 2-digit number can be flipped as well. So the 2-digit numbers can be flipped. Could be, so the first digit, so 0 cannot appear as the leading digit, right? So actually we cannot use this 0, because 0 cannot be put in the first digit, and it cannot put the last digit because it's flipped. It should be a 0, 6 or something like that, so it's illegal. So actually, there is no 0 can be used. So we can only use the 6-letter number. So that can be flipped. There's a 6, so 6 times 6. So we can form 36 2-digit number that can be flipped. Okay, then how? So if a number can be flipped into another number as the question asks us, so we can just remove one of them. So there are 36 of it, so we can remove half of them. But you remember, so there are 6 special number, which is 11, 22, 55, 88, 69, and 96. So this 6 number, they flipped to be their own, which means they cannot be taken away. So there's not another number that can be flipped into them. So this 6 cannot. But the remaining 30 numbers, one can also be flipped to another. So we can remove half of them and only remain the other half. So the one can be removed is the 30 number that can be flipped into another number, and we take half, remain half. So we can remove 15 of them. Okay, now this is for the section B, right? This is for section B. Okay, then we move to the section C. So the section C here, question 21 and 22, actually they are connected by the same properties about Pythagorean theorem, right? Yeah, so question 1, the 21 is easier. It's a very classic question. So we know AP equal to 5, BP 6, CP equal to 7. We want to find the area of DPEF. So this is square, so just we want to find the number of the square of DP, right? So how do we define the square of DP? We want to find the square of a diagonal, which should occur in our mind is the Pythagorean theorem. So to use the Pythagorean theorem, we should build two perpendicular lines, horizontal and vertical, from the point P. And then we get this line, maybe this is an A, this is a B, this is a C, this is a D. So now the 5, 6, 7 and the unknown one, DP, are the diagonal of 4 rectangles. So for 5, we have the square of A plus square of B equal to 25. For 6, we have the square of A plus square of C equal to 36. For 7, we have the square of C, square of D equal to 49. And for the question mark, we have the square of B, square of D equal to the question mark. So how do we get the question mark? So compare with 1, 2, 3. Can we use the 1, 2, 3 to calculate the 4? Yes, it's very easy, right? So we have the 1 plus 3, we have the A, B, C, D. And the 2 is the AC. We want the formula 1 plus 3 minus the 2, we should get directly the B square plus D square. So it's just 25 plus 49 minus 36, which may make it into the answer is very old question. Okay, now this is an easy question. So I think this. So I may not just make it easy. This is a normal question, right? I leave no mark on it. So leave no mark on it. Okay, now about the question 22 is a difficult question. Yeah, maybe 2 question mark? Yeah, maybe 2. Yeah, maybe 2 stars. Yeah, maybe 2 stars. So now here, so we have a 5.5 matrix. 1, 2, 3, 4, 5. Yeah. So on each point, so actually it's about in center of square, but it's the same, right? So now the center of square is represented by the vertex, by the 25 vertex. Okay. So now we arrange some people on the vertex. Yeah, we arrange some people on the vertex to make it into. So make the distance between any 2 people are distinct. So how many people are there? So actually, the key point to solve this question is first to find out. So how many different distances can there be? The key point is, so each one will have a distinct distance. So in this diagram, if everyone is standing on the vertex, so how many different distances are there? So let me have a look. So firstly, if 2 men are standing on the same line, right, they're both horizontal and vertical, so if they're on the same line, the distance could either be 1, 2, 3, or 4, right? But if they're not standing in the same line, they are standing in the diagonal of two rectangles. Then we can see maybe here, right? So here, here, or here. Then their distance should be the length of diagonal of a rectangle. Yes, it's also about Pythagorean theorem, right? So it's also about the Pythagorean theorem. And then this rectangle can be 1 times 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, 3, 3, 3, 4, and 4, 4. Right? So actually, there are 10 different shapes of rectangles, determines 10 different lengths of diagonals. Use the Pythagorean theorem, you can confirm that all the diagonals are of the different lengths. So now here, there are 4 distances, 10 distances. So in total, there are only 10 different distances. It's about 14 different distances that can be formed by the two vertices. So now we can see if there are n people here, and this n should not be more than 6, because if the people n is, if there are 6 peoples, then we have people, not peoples, right? So then, by connecting each of them, we should have choose 2 from 6. So we should have 15, right? So then we should have 15 distances between any 2 of them. Now you can see we only have 14 distinct distances, and we need 15. So it's greater than 40 by the pigeonhole theorem, so there must be same number, must be same value, which is not possible. So there should be less than 6 people. So the maximum is 5. But if you get here, you can only get 10 points. I will get a -5 point for you on this question, because you just proved there could not be 6, but you do not prove that there can be 5. So you should give us an example, so how this 5 can be possible. So I will give you the example like here, 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 and here. So in the combinatoric, not only should we prove that 6 is not possible, you should prove 5 is possible. Then the maximal can be 5. Yeah, so this question. So on the other hand, if you just give the example 5 and tell the answer is 5, you will get only 5 points. You will only get 5 points, as you do not prove 6 or larger is not possible. So to prove the larger is not possible, it's more important than prove this number is possible. So the example was 5 points, and the proof was 10 points. Okay, now, yeah, that's the run through for the P5. So let's look at this. So in the P5 here, so we remember in the first section, we have 8 easy, 1 normal, easy, normal, and 1 difficult. In the second chapter, right, we have 2 easy, I think 1 normal or 2 normal, 5 difficult, and 1, so extremely difficult, or super difficult, just an S, right? And in the, right, and then in the, this is 3 point, this is a 4 point, and about the 15 point, we have 1 normal and 1 super difficult. So how many questions do you get correctly? So I think for normal student here, so it's necessary to get all the easy question correct. So if you can correct all the easy question, your score would be 32. Yeah, 32. So 32 is for silver. And if you can get all the normal question and half of the difficult question correct, you should reach an 60. So 60 is for gold. About platinum, I think platinum should get at least 85. Yeah, the top three, right, should at least get 85. Okay, so now this is the run through for the P5 paper. Okay, maybe we have a break for 2 minutes, right? So we break for 2 minutes and 3 minutes, 3 minutes, and then we will continue working on the P6. So I suggest all the P5 students, you can wait and listen the P6 run through as well, because in P6 and P5, in the primary MO part, they are all the same. Yeah, I think they are not all the same difficulty. So you can see how many questions you can answer correctly in the P6 paper. Okay, have a 3-minute break, and we will be back. Okay. Okay, now come back. Yeah, let's start with the primary 6, the sample paper of primary 6. So the difference between primary 5 and primary 6 is that we have 3 or 4 questions in the primary 6 that will have the primary school, the secondary school. We should use some secondary 1 knowledge to solve it, right? So, but the other part, the other 19 or 18 questions, they are just the same. Okay, Then in the P6, the question 1 is an easy question. So just to find something that is unchanged. This is very, actually this is very easy to make mistakes actually. So there are 500 kilograms of fresh grapes. So firstly, the water content is 50%. And then after drying, the water content becomes 20%. So initially the total weight is 200, right? It's 200. So to solve this question is just to mark if we are drying these fresh grapes. So what is unchanged? So the unchanged is the nets of the grape, right? So the nets remain unchanged, which makes we can use this unchanged method to solve it. So now we can see the total weight is 200, which makes the water to be 100 and the nets to be 100 as well. So now after drying, the nets is still 100, but now the water only works for 20%, which makes the nets will worth 80%. So we use 100 divided by the 80%, we get the total to be 125. And then the total weight reduced by 75. This is the loss of water, so we choose B. Yeah, easy question. Okay, yeah, Chen, someone is asking for 微信客服. Yeah, in the WeChat stream. So maybe you can answer it for me. Okay, the question 2. Yeah, the question 2 is that, so there is a pen. So one pen worth, the cost of one pen is $10.9 and they sold at 14. So if we sold 4/5, so we have a profit of 150. So we should find the total number of pens. So which is very easy if you use the algebra way. So we assume that there is U pens, right? So assume there be U pens. So the cost of it is 10.9 U. This is the cost. And we sell 4/5 U's at the price of 14. And then we have a profit with 150, which means 150 plus the cost equal to the total sales, right? So then we can find the answer easily. So we can solve it and then find the answer. So the answer to be, that is the P6. So the answer to be 500, right? We should see. And easy question for 2. Also easy question for 3. So now here we have AE over BE 102, CF over DF is 72. We know the area of ACE, we want to find the BDF. So you can see with ACE we can find the ABC, right? So ABC would be 3 times of AEC. So which is 6066. And ABC is half of the parallelogram, and also it's BDC. So BDC will equal to ABC, which is also 6066. And then we find the BCF. Then the BCF here should be 2/9 of the BDC. And then we can get the answer easily. So the answer is 4718. So we choose E, none of the above. Easy question. 4 is an easy question as well. So actually, so this you can just calculate step by step and you will find, so this will equal to 1 just directly plus 100. And for each delta here, we use a -2, so minus 99 twos. And then we get the answer. So the answer should be 4852. Yeah, choose E. Yeah, sorry, choose C. Easy question. 5. Yeah, 5 is a normal question. It's not an easy question nor a difficult question. It's a normal question. So here we have the Flash. So Flash stands here, and he has a bullet shoot. And 4 seconds, yeah, not 4 seconds. So the bullet shoot for several whiles, and then the Flash starts chasing the bullet. And after 4 seconds, the Flash catch up the bullet. So the second step is the Flash chasing the bullet. And then, after 8 seconds, the Flash reach the, yeah, I should draw it longer. Just I made picture smaller to make a right proportion. Yeah, okay. And then after that, the Flash runs for another 8 seconds to reach the target. This is 8 seconds. So this is a 4 seconds. This is 8 seconds. And then the Flash returns back and meet the bullet again in 4 seconds. But, yeah, as suggested, so the Flash speed in the last process is only half the speed of its region. So in this step, the speed is half. So we want to find the total time taken from the moment he fires the shot and start running. So about the times in the first step, right? So now here, it's all about the proportion in the journey. So maybe we assume, right? So maybe we assume the speed of the bullet to be 1 and the speed of the Flash to be u. So in the second process, it travels at 4 and for Flash travels for a 4u, right? Then move on. In this 8 seconds, we can see, in this 8 seconds, the Flash traveled 8u and the bullet travels an 8. The last 4 seconds, the bullet travels 4, and the Flash, however, is not 4u. The speed is half, so it traveled only 2u's. And by then, we can see the 8u will just equal to 12 plus 2u, which gets the u equal to 2. So when u is equal to 2, then 4u equal to 8. So now, before the Flash start, the bullet has traveled for the distance of 4, which is in 4 seconds, right? So now we can define that it can be calculated as the Flash started 4 seconds before the bullet, choose A. So you can simply draw the picture and find the answer, but the proportion journey is always not that easy, so I name it as a normal question, not an easy question. And for 6, it's a normal question, but it's not because it's difficult, because it's hard to be correct. It's about counting the figures, right? The figure counting is always not a difficult question, but it's very hard to get a really correct answer. So we should calculate the right angle triangle in the diagram. So not about triangle, it's right angle triangle. So now here, if we want to calculate the specific type of triangle, so we can focus on the characteristic of this shape. For example, now here we have the right angle triangle, which means we just should find where do we have the right angle. So actually, there are 2 different places that have right angle triangles. So first, right, it's ABCD, right? So it's ABCD. So can we form any right angle triangle with this ABCD? Obviously we can. So for each angle, there are 2. So 1, 2. Right? So use ABCD as the right angle. We have each angle have 2. So totally 8, right? Totally we have 8. And also there is another place we can have right angle, which is here. Right? So this is the right angle. And this point exists. There are 8 of such points. M1, M2, M3, 4, 5, 6, 7, 8, right? So then we just calculate 1 and we can times 8 to have the answer. So in each of this point, there are 4 right angles actually, and each of these 4 right angle can have a right angle triangle which is 1, 2, 3, and 4. The smallest 4 here. So in M1 to M6, M8 as right angle, in each point we have 4 of them, and there are totally 8 points, right? So there are 8 points. So sorry. I missed it. I missed the 2 large triangles. So there is a 5 here, and on the other side we have the 6 here. Actually 6 here, not 4. It's 6. 6 here, so it's a 48. So you can see. So I create this question. So I do question before, but I still is easy to make mistakes. So this is why I mentioned. So figure counting is very easy to make mistake, and it's hard to get correct, right? So now we can see, in each of the M we have the 6, and 6 times 8 is 48. So adding up together, so in total, we should have 48 plus 8, 56, which is E, right? So now this is the normal question. They're not difficult, but not easy. Obviously not easy. Okay, for 7, 7 is a very, I don't know how to define it. So it's just about whether you have seen this question or not. So if you've seen this question, you learned this question before, it's easy for you to get the answer. If not, it's not that easy to think about it. So this is the fraction calculation, and the numerator is 1, we just do the denominator. And the denominator is formed by 2 parts. So by observing each part here, you can see, so each part here, the denominator is the production of 2 numbers. And it's a very typical type for the fraction splitting, to split it into the sum or difference of 2 other fractions. So, but how to split it? So to split this, we should either make the numerator to be the sum of them or the difference of them. So we can adjust this numerator as they're all 1, but to become sum or difference, actually it's the sum, because in these denominators, the sum of the 2 factors are always the same. It's always equal to 2008, right? So then we can define it as, if we put it into this way, just the denominator. So in the first bracket, we can just put all numerator to be 2008 and times additional 1 over 2008 to be equal. And now here, the numerator is the sum, the denominator is the production. So we can split it into the sum of 2 fractions, which is 1 plus 2007, 2 plus 2006, until 2007 plus 1 times 1 over 2008, right? And for the second bracket, it's easier, as so the sum of the denominator is the 2007, and we have a 2007 here. So we just put this in. So we have the 1, 2007, 2007, and then 2007, right? And for the same reason, it can be split into 1 plus 2 plus 2, the last 2016 plus 1. And obviously, all the fractions are calculated twice. So now the first bracket is 1 to 2017. And the second bracket is 1 to 2016. And outside of the bracket is 1 over 2008. And then we can see, so all the 1 to the 2016 should be cancelled, right? So the only remaining is just the 2007. So the remaining part is like this. And denominator is here, then the original fraction should be one over it, which makes it to be like this. And the answer for this question is E. Should I name it a difficult question? I think not. It's a normal question. It's a normal question. Yeah. And for 8, it's an easy question for 8. So now here we have Amy completed 5/7 of her task. Linda completed 17% of her task. And then the finished and the remaining is the same. The remaining is the same. So we may just zoom the remaining part, right? So now this is a 30% and this is a 2 over 7. So maybe we just label it for 6u. So if the remaining part is 6u, and then we will have the finished part or the total part to be, now this is 2 over 7 of, and this is the 30% of the total part, right? So if you zoom it to be 6u, and the total value should be, now here we have the 21u, and here we have the 20u, right? So then u should be an integer, right? U should be an integer. So then we have the a and b here should be 21u and 20u. So the sum of all this total is 41u. And we know that this 41u is more than 200, and u is an integer. So the minimal value of u should be 5, and the minimal value for total is 205. So we choose E. We choose E. Easy question for this. For 9, right? So for 9, actually, if you use the model way, it's a little bit difficult. You should draw the rectangle diagram and to solve it. But yeah, if you use the algebra, algebra is easier, but you will face some problems. So I just use the algebra way to make it easier. So there are some clocks. So they have the unit, they have the amount, the number, it's countable. So we have the number and we have the price. So maybe the first day the number is X, the price is Y. And the second day, the price is increased by plus 300 and is sold 8 less. The third day, the price increased by additional 200, makes it into 500. And then the number sold is 2, even fewer, which is X minus 10. So now, how do we solve this problem? So as you can see, so for each day, the sales is all the same. The sales is the production of the number and price. So which makes 1, 2, 3, they all are equal. So maybe we have the xy equal to this x minus 8, y plus 300, and also xy should be equal to x minus 10, y plus 500. So it looks like a quadratic, but actually you can cancel the x times y. So make it a linear expression. So the first one is 300y minus 8x equal to 2,400, which the next part is 500y minus 10x equal to 5,000. then we can get the value solved it out to be x and y. So x will equal to 16 and y should equal to 300. So the answer question is asked about the price in the first day is about y, so we choose the 300. So this is the easy question, I think. So as long as you know how to use the algebra way, if you want to use the model, it's okay, but it's more difficult. For question 10, I think is a normal question, so not all students have learned this, but I think this question is quite often occurs in both NEMOS and SMOPS, right? So this is about, right, this is a fraction, and a fraction is a natural number, which means the denominator should be the factor of the numerator. And there is an unknown term n here, so we should cancel the n, at least cancel the n on the right side. So how do we do this? We try to form a same expression at the left. So on the left, we have 2021 minus n. So on the left, we create another 2021 minus n. And then we minus an extra 100, right? So we just plus at 100. So you see, this one is obviously a multiple of the left. It's itself, right? It's minus 1 times itself. So this one is the multiple of the left, and the total is the multiple of the left, which makes the remaining should be the multiple of the left. So then we make this 2021 minus n is divisible, it's a factor of 100. And then we just need to find the factor of 100. So 100 is the square of 2 times square of 5. So totally there should be 9 factors. But it should remember that n is larger than 1921. So which makes the difference here cannot be 100, right? So if it's 100, then n equal to 1921. So not possible. So 9 minus 1 is an 8, right? So the value can be choose is the 8. So we choose B. So this is a normal question as it quite often occurs in the NEMOS and SMOPS. So I believe, so at least half of you should have learned this before. So I have run through this in our NEMOS second round, right? NEMOS second round countdown, right? Yeah, you can see it here. Okay, so this is about the first section. And we move to so maybe we do some statistics. So 1, 2, 3, 4. 5, 6, right? So in the first section, we have, I will note it at the backyard. So in the first section, we have 6 easy one and 4 normal one, right? We have 6 easy one and 4 normal one. Okay, then we move into section B. Yeah, section B, the question 11 is maybe a difficult one, but the answer can be guessed, so not that difficult. So here we should find the difference between the area of blue and red. So how do you find the difference? So there are 2 ways. So I will just introduce one way. It's about to use the symmetry to help us. So we want to find the difference. So there should be the common part. So we find the common part, and the remaining is the difference. So for example, the first red part is BEG, right? So can we find the blue part that is equal to the BEG? We can, because these 2 lines are equal. So we connect AG, right? Connect AG. So we can see these 2 parts, 1 and 1, are equal, right? They have the same height, they have the equal bottom, so they are equal. And then we have the AGH here. So then this here we left a blue triangle. So can we find a red triangle that have a same area with it? Yes. As A is the center of the circle. So we connect AI, and for the symmetry reason, 2 and 2 are equal. Then we have another red triangle, which is ADI. So we just connect CI for the same reason, 3 and 3 is equal. So actually, the difference we want to know is just the area of this FCI. It's just this FCI. So how do we get this FCI? At actually notice that they are parallel lines, right? So DI and CF are parallel, and CF is the bottom. So we can see this CFI just equal to the CFD. So by using the same area transforming, so CFI equal to CFD. And CFD has the bottom of CD and the height of DF. The height of DF, right? So as this is just the radius of this circle. So now the bottom is CD. The radius is a 6, makes the BEAE, they all be 3. Yeah, they all be 3. So now here we have the AF to be a 6. CD to be a 3. So the difference on area is a 9. So it's irrelevant with the pi actually. So there is a hint. So if you're facing a question, the question does not tell you what's the value of pi, then that means you do not need to use the value of pi. Yeah, so for this one. Okay? Now, question 12. Yeah, this is a secondary school question, but it's very easy. So I will not name it as a difficult question, just a normal question in secondary school. So as long as you learn you do some pre-learning for secondary 1, only secondary 1 only. So I think the primary 6 student at this, so my student here, so my student at primary 6 at this age have already finished the secondary, at least secondary 3. So maybe the secondary 4 or JC 1. Yeah, if you want to learn competitions in the secondary school, you should learn in advance. Okay, so now here, if the cube of A plus cube of B equal to 34, A plus B equal to 4, right? So now how do we get the A square plus B square? So this is about Gaussian sum of powers, but we do not use the complex way. We just use the factorization. Use the factorism to help us. That's really okay. So now we see that this should equal to A plus B and A square of A minus AB plus the square of B. And we know that A plus B equal to 4, which leaves this, right? This is equal to 34. So which makes A square minus AB plus B square equal to half of 17. Okay then. For this one again, we change it into the sum, the square of sum of A and B, and minus 3 of the AB equal to 17 over 2. And then we have this to be 13, right? This to be 13. Then we have 3AB equal to this, and AB equal to this. And then how do we get the A square plus B square? Because the A square plus B square can be written as the square of A plus B minus 2AB. So it's 4 square minus 2 times 5 over 2, so it's 11. Yeah, it's a normal secondary school question. I think it's easy for primary 6 students. So as long as you have the thought to enter the secondary school competition, if not, then ignore it, right? If not, then ignore it. Okay, the question 13. The question 13 is called that if the largest factor of a natural number is equal to the product of all its other factors, we call a number a perfect number. So now here, so if we list one number, right? So for factors for m, the smallest should be 1. The largest should be n. For one number, so the largest and the smallest has a production of itself. And so is the second largest and the second smallest. So we can see the second smallest may be an A, the second largest may be an B. So we have A times B to be equal to n as well. And if we want this number to just be all the other factors except for it, so we have 1 times A times B equal to just n. So which means as long as this number has 4 factors, so this perfect number will just mean this number has 4 factors. So we just want to find the numbers between 2 and 100 which will have 4 digits. 4 factors. And the number of factors is determined by the form of prime factorism. And there have 4 can be written as 3. So now n can be the cube of one single primes. Or 4 can be written as 2 times 2. So it can also be the form of p times q. So let's have a look. So if n is the cube of one prime number, so p can either be 2 or 3. So for p equal to 5, the cube of 5 equal to 125. It's larger, right? So then for the second process, it's more complex, right? So p times q, the production of 2 different prime numbers. So we may just listing up from smallest to the largest. So smallest prime number is 2. 2 can times for 3, 4, 7, and the largest is 47. And if 3 can times for 5, 7, 11, and the largest can be 31. We just count all the prime numbers. And for 5, we have the 7, 11, and the largest is 19. So we counted. So for 2 is 3, 4, 7, 11, 13, 17, 19, 23, 29, 31, is 10 of it. 37, 41, 47, 43, 47, 14 of it. So this is 14 of it. For 3, it's easier. 5, 7, 11, 13, 17, 19, 23, 29, 31. It's 9 of it. For 5, I think we do not need our fingers. So it's 7, 11, 13, 17, 19, 5. For 7, it's 11 and 13 on the 2. There's no for 11, right? So in total, we will have 30 of it. That's 30 of it. So 30 here, 2 here. So together is 2 plus 30 equal to 32. So there are 32 perfect numbers. 32 numbers with 4 factors. So this is a normal question again, not that difficult. So the 14, right? So I just run through this question in my primary 4 CO. So this is in your primary 4 CO. So I think for P6 student, it should be listed into an easy question. So now it says that a ship traveling from A to B and take them totally 8 hours. And the first 4 hours, it travels 16 kilometers more than the last 4 hours. And we know the water speed is 10 kilometers per hour, and then we should solve the distance between A and B. So how do we do this? The key point is, so from A to B, we are traveling downstream, which means I traveled faster. So the downstream will cost less than half the time, so less than 4 hours, and the downstream will cost less than 4 hours, and upstream will cost more than 4 hours. So which means the last 4 hours is always used for the upstream, right? And then the first few hours we have the downstream time, and maybe we have the upstream time. So the difference on the distance is because in the first 4 hours we use the downstream speed to travel. Then it's about the distance, it's the difference on distance. We should find difference on speed. So the difference on speed, so the water speed is 10 kilometers, and the water speed is half of the speed difference between the downstream and upstream. So we have the downstream minus upstream is 2 times water speed is 20 kilometers per hour, which means the first hour, downstream versus upstream, we would have 20 kilometers more. Also, for the second and third, right? So we should also have traveled for 20 kilometers more. And you know that after 3 hours, the distance difference is just the 30 kilometers, which means in the 4th hour and the 8th hour, they traveled with the same distance. So that means in the 3rd hour, it finished reaching the B, and in the 4th hour, it had turned down, right? Turned over. And in the 4th hour, it starts traveling in the upstream speed, so which makes it the same. So use the difference on distance, we can determine the time it travels from A to B. So it used 3 hours for downstream and 5 hours for upstream. But for downstream and upstream, they travel in the same distance, right? So same distance, the ratio of speed equal to the ratio of time. The controversial ratio of time. So which means the ratio of down speed to upstream equal to 5 to 3. And then we know the speed difference is 20 kilometers per hour. Then we can determine the downstream speed is 15 kilometers per hour. And it traveled for 3 hours. So it's 15 times 3, which means 150 kilometers. Yeah. Okay, so this is an easy question. Question 15 is just about a normal question because it's just a brainstorm. So let's see. So each Johnson number has a sum of prime number, which means 1, 3 should be adjacent to 2, 4. Yeah. So all the 1, 3 should be adjacent to 2, 4, and which determine the parity of this. So I colored this 4 times 4 into 2 colors, red and white. So all the red, so as odd can only be adjacent to even can only be adjacent to odd, which means that all the red should have share the same parity, and all the white should share the same parity, right? Okay, then as we can see, so all the numbers have a common vertex to not be same. So we start from the top left. So the top left, we will have 4 choices. It can either be 1, 2, 3, or 4. Right? So here we have 4 choices, just name it to be 1. Then we can determine this one it can only be 3, right? So this one can only be 3 because each odd number it could not be same with 1, so it's a 3. For some reason, this should be 1, this should be 3, this should be 1, 1, and 3, 3. So actually, as long as you determine the top left, you can determine all values in the red zone. And also, for the white, so these two are either 2 or 4. We can determine this one. We have 2 choices of it. So it's either 2 or 4. And if we write 2 here, then this must be 4, 4, and this is 2, 2, 2, 4, 4, right? So actually, the 2 blank at the top left just determine all the other squares. As long as you notice this, it's very easy for you to solve this problem. Okay. Yeah. So, but not that easy to think it out. So maybe it's between normal question and easy question. So the likely to be the normal question. Yeah. Okay. 16. Yeah, 16 actually is the difficult question. Maybe not. Maybe normal question. So the sum of digits of the two 4-digit numbers differs by 1, but the difference is 700. So now here, right? Yeah. Oh, okay. Now this is a difficult question. No, I know the 3, so this is not that easy. So now here, the first 2 questions is about the sum of digits. So we know that this number is 1 is the A, and 1 is the A plus 710. So you can see from here. So when I plus something, so when we do the addition, the sum of digits is determined by adding the 2 sum of digits and the minus the time it carry over. So you can see A has a sum of digits to be SA. So now the sum of this is SA plus the sum of digits of 701 is N8. Then minus what? So minus 9 times the time of carryover. So as the difference between these 2 sum of digits differs by 1, which means there must be 1 carryover to be this SA and SA minus 1. So these 2 just determine that when adding them up, there should be at exactly 1 carryover with right. Okay, Now the core is about a third. So the last 4 digits are the same when each number is squared. So if two numbers, right? So if two number is squared, and the last 4 digits are the same. So what is the last 4 digit? Actually, the last 4 digit is the remainder divided by 10,000, right? It's remainder divided by 10,000. So if they share the same last 4 digits, it means they share the same remainder when divided by 10,000, which also means that 10,000 then should be the factor of their difference. And then we can use the formula in the difference of squares. So now here is the sum times difference. So the difference is 701. The sum is 2a plus 701. So now you can see, so here we can cancel 1, 0 here. So now this we can cancel a 2 here. So we cancel a 2 and cancel a O here. So which makes this one to be a plus 355. And now here is a 500. So which makes it to be 500 is the factor of 71 of a plus 355. And as we all know that the 71 is coprime is 500. So will lead us into 500 is the factor of a plus 355. And then a plus 355 is a factor of 500, which means the last 3 digits of this a can either be 145 or 645. And the first digit of a can either be 1 to 9, right? But yeah, it's also need to take into consideration that the carryover when we plus this one, it should have 1 time for carryover. So in this case, we do not have carryover, so no. In this case, it's good, right? So this is good. So exactly 1 carryover here. So the last 3 digits for a could be 6, 4, 5. And the first digit can be 1 to 9, but 9 is not possible. 9 is not possible as if it's 9645, then it plus 710, it should become a 5-digit number, which is not possible as this is a 4-digit number, right? So it can either be 1 to 8. So 8 different numbers. Okay, this is a difficult question. 17 is a normal question. Actually, it's an easy question. So as you know how to calculate this out. So actually, so there is a conclusion that if a and b for the Gaussian symbol, so if a plus b is an integer, but a and b are not, then we have the integer part of a and b, the sum of it is just equal to the sum of a and b minus the 1, because the fraction part of a and b should form an exact 1, right? So using this, we can use the pair strategy to pair this formula from top to the end. So it will equal to this and so 17 and 23 are coprime, so which means all these numbers are not integers, but the sum of them is 17 times 69 is an integer, right? It's an integer. So we form several groups like this. So in the middle, it should be right? So we form it by groups. But here we should notice something that is easy to make mistakes. So if we want to use this pairing strategy, we should ensure that each number here are not integers, but the sum are integers. Of course, the sum of them are all integers, but there are 2 specific numbers who itself is integers, which is the 17 does not work, but this is 17 times 23 and 17 times 46. So these two, they are integers by themselves. So they cannot use the pairing strategy. We just calculate their own. So the first group, right? So in here we have 68 numbers. So 66 of them are pairing into group. So firstly we have 33 groups. So the sum of each group is the sum of the inter number, which is 3 times 17 and minus 1. And for the last two, so this is 17, this is 34. And this is the answer we needed. And so we get the answer to be 1701. Yeah, this is a normal question. As long as you learn this, you know how to do this, right? Okay, move on. So the question 18 is about the strategy problem. So this strategy problem is, so there are 14 in the box, and take turns to remove, and each time cannot take more than 1/3 of it. So now Eddie takes 3, so there is only 37 remaining, right? So for this strategy, the key point is to, step by step, we find the winning point and the losing point. The winning point is that when I see this number, I just pick a number and I will win. The losing number is when I see this number and I'm turn to pick, I will absolutely lose. So firstly, so if one cannot take any more candies, so it's if, right? So if the remaining candy is 1 or 2, it is called the losing point, right? Because when I see 1 and 2, I cannot do anything. I cannot pick any candies. I cannot take more than 1/3 of it, right? So 1 or 2 is the losing point. And for any point that can pick into a losing point, it's a winning point. If I can make you lose and I win. For example, 3 is a winning point, right? 3 is a winning point. So any way that can lead you into a losing point is a winning point. And on the contrary, so if there is a point, all the method I can use will get you into a winning point. It's my losing point. For example, 4 is a losing point because that 4 can only lead to 3, and 3 is your winning point, so it's my losing point. So using this, we can determine. So 5 is winning. 5 can get into 4. 6 can get into 4. 7 is losing point. 7 can get only into 5 and 6. And 8 to 10 is winning. They can all get to 7. 11 is losing. 12 to 16 is winning. 17 is losing. 18 to 25 is winning. 26 is losing. 27 to 37 are all winning. So actually 37 is Vicky's winning point. But he wants to win, so he should make the Eddie into the losing point. So he will make Eddie into the 26, so which means he should take 11 of it. Yeah, should take 11 of it. It's a basic strategy. So this is not easy, it's a normal question. So the normal question definition is that you may haven't learned this. So this may not be in your learning syllabus, right? You may fail to learn this, but as long as you learn this, it's easy for you to solve this question. So this is the definition of normal question. Yeah. 19 is a difficult question. So if in the primary school we use the hypotenuse diagram, but yeah, if you treat it in secondary school way, we can use the root 2 to solve it. So it depends on the way you solve, right? So the side length of this is 12, and we want to find the area of the shaded region. So how does this shaded region come from? Actually, the shaded region can be cutted into 6 of this triangle, right? So the shaded region can be treated as 6 of this triangle, okay? 8 of this triangle, so 8. So this is 1. Yeah, not this one, this one. Yeah, this one. We have 1, 2, 3, 4. Yeah, and 5, 6, 7, 8. Right? So it can be formed by 8 of this type of triangle. So we just calculate one of this triangle. And for this triangle here, as we can see, we already have the bottom to be 12. So we just need to get the height of it. So we just draw the height here. And you can see it's adjacent to this triangle, which is an associated right angle triangle. And we can use the symmetry, or we can use the chord diagram. So we can just draw the height here. We draw the height here, and with the symmetry reason, I'll use the characteristic of the hypotenuse diagram. So these two are equal. So the height here, we will name it as this A, B, C, and this is an H, and this is the M and N, right? So we have the MN equal to HC, and for symmetry reason, HC equal to half the BC, which is a 6. So this is a 12, this is a 6. So now we can get the BMC equal to 12 times 6 times a half is a 36. And the shaded region is 8 of the 36. So the answer is QAA. Okay. Right. Yeah. Okay, for 20. 20 is a normal question. 20 is not a difficult question. So it's about picking up. So here is a rabbit. The rabbit should pick turtles at 7 o'clock. But rabbit forcibly for an hour. So which means the turtle started from the 7:20 and start walking. And on the way, he meets the rabbit. And then the rabbit pick it up back to his home. So now the rabbit speed is 17 kilometers per hour, and we want to determine the speed of the turtle. And the only thing I know is that the rabbit is 1 hour late. But actually, they reach the destination only 15 minutes late. So I started 1 hour late, but I reached the goal 50 meters late, which means the rabbit have 10 minutes less on the way, right? So the key point is that then why does the rabbit have 10 minutes less on the way? Because normally he should go here and there back, right? But now he just meet the turtle at the middle of the road, which means he traveled. This part is the destination. This is distance. The rabbit traveled less. So he has 10 minutes on the way, which means the rabbit traveled this distance for 10 minutes. So as it's for 10 minutes, which means that for one single journey, it would take rabbit 5 minutes. So we mark this A, B, and C, right? So then we have the rabbit would take 5 minutes on BC, right? On BC. And then we can determine. So you can see the rabbit should arrive at B at 7 o'clock. So normally it would reach point C at 6:55, correct? And then this day rabbit is 1 hour late, which means this day rabbit reached the point C also an hour late. So which means the rabbit reached the point C at 7:55 p.m. a.m. So this is the time for rabbit to reach the C point. And at this point he meets turtle. So turtle also reached point C at 7:55 a.m. Then we have the turtle, right? turtle start from 7:20 and reaches point C at 7:55, which means the turtle would take 35 minutes on BC. And for the same distance, the ratio of speed is the controversial ratio of time, so which means the speed of rabbit to turtle is 7:1. And then the rabbit speed is 70 kilometers per hour, then the turtle speed is 10 kilometers per hour. Okay, so this is the normal question. Yeah, so let's see. Here we have 1, 2, 3. Yeah, only 3. Only 3. Yeah. So we only have 3 difficult questions. Yeah, it's in P6 level, right? Yeah, I think it's okay. So in the second section, we have 1 easy question, 3 difficult questions, and 6 normal questions, right? 6 normal questions. Okay, about question 21 and 22. So 21 is easier, and it's a difficult question, and 22 is also a difficult question, not an extremely difficult question. Yeah. So question 2 is the question created by me. So there are in P5-P6 sample paper, there are 3 questions that are created by me. I'm the originator. And in your official test, right? In your official test, there will be around 10 questions created by me. Yeah. No, more than 10. Yeah. In P5 and P6 together, we will have 15. Yeah, around 15 created by me. Okay. Now the 21. The question 21 is that there are 10 minutes separated into 3 groups. So there are groups A, B, and C. So the average of this is 6, 8.5, and 12 separately. So the total number is 10. So the question is, so we want to find the one with the largest weight to be the smallest. So what's the smallest value for the largest weight? So this is a very typical extreme value problem, right? So of course, we want to find the largest. We notice the 12 here, right? So here, the average is 12, which means that there should be at least 1 person no less than 12, or there should not be average. So actually, we can start from the 12. So as we know, the largest can be no smaller than 12. So the first case, if the largest equal to 12, what will happen? So you can see, if the largest is 12, then this average should just equal to that man's weight, because there is no one greater than 12, so there should be no one smaller than 12. So C would have 1 person with the weight of 12. So my average is my own, right? So this is the first case. And then we can see, yeah, if it really works, so C has a 12. What will happen? Then we look at B, right? So B has average 8.5. So which means the number in the B must be 2, 4, or 6, right? So if B have 2 people, right? If B have 2, then the sum, right? We calculate the sum. So if C has a sum of 12, then B's sum can either be 17 or 34 or 51. Yeah, 2, 4, or 6. So let's compare with it. So as we all know, the number of people here, so it takes 1 people, it takes 2 people. So now if B is 17, then A should have 7. So A should have, if B have 2, then A have 7, right? So B have 2, the sum of B is for 17. A have 7, the sum of A should be 42, which is not correct. as we can see, any one group is smaller than the sum of other two groups, right? So this is not correct. So then, if B have four, then the sum of B should be 34, and A would have 5, and the sum of A is 30. Yeah, this is good, right? So 12, 34, 30. This looks good. But it's not possible. Why is not possible? Because in that case, A plus B will equal to 36. But we suggest what? So we suggest the largest number is the 12. So in means in the group A and group B, they should be no greater than 12. So they should be smaller than 11. But we notice that there are 9 numbers. So starting from 11 is not 11, 10, 3, right? So this is the 9 numbers, which is not exceed 12. So this is the largest possible value of A plus B. But here, the value of this is 63, which is smaller than 64. So in this case, the number looks quite well, but it cannot, right? So the largest number cannot be 12 because the number smaller than 12 cannot add up into a 64. So the largest number cannot be 12. If not 12, then the largest equal to at least 13, right? And 13, we can get a very easy way to find the answer. So if you wanted 13, so the average is 8.5, and this is 12, right? So the content, we just make C into a 11 and 13. So it has the, just write the sum here, right? So the sum is 24. And now here we can have B, make B to have just 2 people is 17, which we can use 8 and 9 to do this. And A, we should have 6 persons, the sum of it is 36, and 6 people 36 is very easy, so we can just use the largest number is 10 and 12, and it's 22, and we have the 1, 2, 3, which are 6, and that have, yeah, no, it's smaller, so 12, 4, 6, right? So what's remaining? So 22, now this is 31, then times 5, you'll be okay, right? So this is possible. So 12 is not possible, 13 is possible, so the largest number is can be as small as 13, okay? So now this is a little bit difficult, but not that difficult. And the question, and the 22 here, right? 22 here is maybe the most difficult question here. As it is a secondary school question. Yeah, not a secondary question, but you should ask you to use the secondary stuffs. So we should choose n distant. Our paper there are n distant rational numbers, and if we choose 3 of them, we can always find 2 of them, and the production is written as well, and to find at least at most how many numbers can we write on the paper. So this question is I created for the 2022. Yeah, created for the 2022 Yinchun Bay in China for the for the secondary school. Yeah, and I think very interesting question. It's not that difficult. So firstly, if we write too many numbers here, for example, yeah, it's easy to find. If we write, for example, 2, 3, and 4, right? So if we write 2, 3, and 4 here, if there are 2, 3, and 4, so we choose from 2, 3, and 4. So there should be the production of the 2, 3, or 2, 4, or 2, or 3, 4. So we must write another, maybe an 6, maybe an 8. Then the number should be increasing, right? So increasing. But there is a limitation. So the number on the paper is finite, which means if we write too many large numbers, the number will increase, and increase, which will make the number infinite, which is not suitable. So the key point is, the first thing is that there is at most three numbers with its absolute value greater than 1. So because the rational number include both the plus and minus, right? So positive and negative. So here we use the absolute value to determine if the number has an absolute value greater than 1. So we product another, we will make each other larger and larger, right? So why is that? So for if there are 4 numbers, which is A1, A2, A3, and A4, right? So if there are 4 numbers, A1, A2, A3, and A4, yeah, the absolute value may be equal, though the number is not equal, right? So it's greater than 1. So then, if there are 4 numbers exist, then we choose, and we assume this to be the 4 largest. The 4 largest absolute value. And we have, now we choose A1, A2, and A3. So now we can see the production of each of them should be larger. So the A1 times A2 should be greater than A1. And A1 times A3 is also greater than A1, which makes these two should not exist in the paper because assume that A1 is the largest absolute value, right? So now does not exist. Which means the only thing that can exist is the A2 plus A3. So the only way that it can, so must be A2 times A3 exists. And A2 plus A3, and this is the absolute value of it is greater than A2 and A3. So it can only be A1. For example, 2, 3, and 6, something like that, right? So this is greater than the absolute value of A2 and A3. The only number remaining is the A1. So it should exist. So A2 and A3, the production must be the A1, right? So it must be the A1. And here we have some problems. So as you can see, so if we choose A1, A2, and 3, we can prove that A2 times A3 must be A1. And what about, again, we choose A1, A2, and A4. And for same reason, A1 times A2, A1 times A4, they cannot exist, right? Because the absolute value is over A1. So then there must be A2 times A4 equal to A1 as well. So A1 times A2 times A4 should also exist. And the absolute value is greater than A2, so it can only be A1. Which will lead into A3 equal to A4. It's not possible. So all number must be distinct, right? So here we prove that. So there should only be 3 numbers whose absolute value is greater than 1. There cannot be the 4th one, right? There cannot be the 4th one. Okay? Then if a number of absolute value is greater than 1, it becomes larger and larger. And on the contrary, so if one number has an absolute value smaller than 1, then 1 times the other should make the number smaller, smaller, and smaller, right? So then, for the same reason, we will have, there is only 3 of them, at most 3 actually, so with their absolute value smaller than 1. Yeah, it's for the same reason. Okay, then, so we have, there are only 3, at most 3 numbers, absolute value greater than 1, 3 numbers smaller than 1. And there, what else? So there could be numbers absolute value equal to 1, which is 1 plus 1 minus 1, and could be 0. So then at most 3 smaller than 1, 3 greater than 1, minus 1 plus 1 and a 0. So at most 9 numbers. Yeah, we classify it by the absolute value. Okay? Then I will give you an example of these 9 numbers. So we have the 0 should be here, the 1 should be here, the minus 1 should be here. So then we have the 1 over 2 and minus 1 over 2 minus 1 over 4. And also we have the 4, we have the 2 and minus 2 and minus 4. Yeah, this is an example. Yeah, you can see this satisfied. So you cannot change this minus 4 into 4, which is not correct. Also, you cannot change the minus 1 over 4 into 4, which is not correct at all. Yeah, so now this, okay? Now this is what we did this question. So this is maybe the very difficult question. Yeah, so in the 21 and 22, we have the 1 difficult and 1 super difficult. So again, we calculate the silver and gold, right? So for silver, you should get all the easy questions correct. But actually this is in the primary set, right? So maybe you should need to get half of the normal question. So all easy question and half of the normal question. So which will lead it into, this is 10. Yeah, sorry, this is 10, this is 5. So 5 here will lead into 15, and 15 plus and 15 plus and yeah, maybe 36. Yeah, in this you will get 36 points if you get silver in primary 6. And for gold is the same. So all the easy and normal, and then half of the difficult. So which makes it to be quite higher. I think this time gold is quite higher. For gold, you may need to reach the 65 point or 70 point. Okay? Yeah, I think that's all for the run through today. And these 2 papers, right? These 2 papers are just to show you the difficulty as well as the contents. Okay? And actually, I have to tell you that the real question is a little bit more difficult than the sample paper. So be prepared and hope you can get good grades. Okay, that's all for today. Thank you. And maybe we can end the stream. If the stream ended, tell me. I have another meeting to go. Or if the stream ended. Never mind, I just quit.